Hello again, everyone. This is Aaron Corcoran, and this is a tutorial on generating 3D tracks once you've already done the 2D detection and 3D calibration generation. If you haven't already done those things, then you need to go back and do that using some of the tutorials that we've shown earlier on. Now, once you're ready to make your 3D tracks, what you're going to do is go up here to File and Make 3D Tracks. This is going to open up a dialog box with options that's similar to what we did before with our 2D detections. The first thing we want to do is select our detection files for camera 1 and camera 2 and our 3D calibration file. So you should have already made all of those at this point. We'll do select files, and it's going to ask us to choose all three of those in order. So we do select files, and if you want to try this with some example data, you can go within ThruTracker, example data, and our 3D track data folder. First, we're going to do our 2D detections, and this is an example that I did with another project where we actually had 4 cameras. I'm just doing it with 2 of those cameras for illustrative purposes. So I'm going to choose camera 1. Data that I generated using ThruTracker, using the 2D track generation. And then I'm going to click on our second 2D detection file. Next, it's going to ask for the calibration file. And I'm going to go to example data, 3D track, and our 3D calibration. And you can select this. I generated with Easy Wand. Or if you made it with Simple Wand, you would select that same Simple Wand file. Okay, now I've selected my files. You can change where and the file name that's going to be saved. The default is to save it with the same name as that first 2D detection file. And so I might change this so I can take out camera 1 and just say 3D data.map. And then we have some options for 3D tracking. So again, it's automatically gone through and found that the first frame where I had a detection was frame 1, and the last frame was frame 499. I want to do all of those frames in this case, so I'm going to just leave those to be the default of what was populated once we selected our files. Then, similar to the 2D track generation, we can have a minimum track length. I'm going to say 5 detections is required for a track in this case. And in this case, a maximum gap length of 10 frames. So in 3D, it's more difficult to get noise that's going to align into a 3D point, so we can have a larger gap length. Next, we have some thresholds to set. There's the DLT threshold, so that's how closely the points match up between your 2 cameras to create a 3-dimensional point. So I'm going to lower this to about 5 pixels. And that's still pretty generous, but that would allow us to detect any 2 points that are pretty close to each other to make a 3D point. Then I have a match threshold, and in this case, I'm going to set that as 5. The match threshold for 3D is a combination of the 2D tracking, which is shown as there's an option here for 2D tracking, XY divisor, and the 3D tracking, you have an option of how you weight those. So in this case, it's going to be weighting the 2D tracking more heavily because I have an XY divisor. It's going to divide the error in 2D by just 1, so it's going to keep that the same XY difference. It's going to divide the XYZ position in meters by whatever I have here, which is 5. So having an XYZ divisor of 5. So if we wanted to emphasize 3D over 2D, we could adjust these numbers, but I'm going to just leave these in default. All right, now we're ready to make our tracks. So we just click Make 3D Tracks, and it will start processing. It processed all the 2D detections and linked them together into 3D tracks, and it saved that data into the file that we specified up here. So I'm going to hit OK, and then this is visualizing the tracks that we had in those 2 videos. And this looks pretty good. So it created 4 tracks, and each circle that it's visualizing is a particular detection, and we can see what those look like. So it's going to test this using some data where you know that there are some detections. Maybe do it for a short clip where you have a particular detection and validate that it's working that way that you want it to. If it's not, you may need to start playing around with some of these parameters. Okay, now that we have generated our 3D tracks, we're going to want to visualize them. So we can close that visualization and we can close the track generation panel. And next, if we want to visualize them, we can go up to Tools and Visualize 3D Tracks. And this is BatVis, which we are developing from a previous version. This is version 3, and we've added some new features if you happen to have used the previous version. So what we're going to do is first populate our visualization with all of the different detections that we're interested in. So I'm going to go up to File, Load Data, and we can do Example Data and BatVis. Select the folder that has your data. So you can do multiple detections, put them all in a single folder, and choose that folder, and it will populate our visualization with all of those tracks. In this case, we have 14 detections from a particular night, and we can sort them. So we can select if we put in multiple nights at different sites. That information is stored in the file name of the data, and then this is automatically populated. So we could select only the tracks from particular nights or locations or treatments, etc. So in this case, we've got 14 tracks, and it is visualizing them over here. So there are some settings in our main visualization. We have some advanced settings, and then we have our wind turbine visualization here. So I have this set up so it's generating the turbine that we used. You can actually change the size of the turbine. We have some options here, so we can change that and update the turbine size. This is kind of an interesting visualization just so you can see how big of a difference some of these turbines look if you look at those individual tracks. So I'm going to go back to this one that we were recording at. And we can rotate this. You can choose some different options to view these tracks in different locations, the overhead view, side view. There's also an animation here, so we can play the animation, and by default, it's going to give you a side view. You can adjust the speed if we want to make that go a little faster, so we can see that. And you can adjust the angle, so we can put that, say, a 45-degree angle and visualize those tracks. Another option is you can select individual tracks and look at their parameters. So in this case, we selected all 14 of our tracks, and the summary of that track information is showed. The average of those tracks is shown in the track summary data. So this gives you information like track length, speed, centripetal force, etc. If you want to see an individual track parameters, what you can do is unselect any of these options up here. You may have select like the rotate 3D, and make sure you have your crosshair. Then you can select an individual track, and it will show you the parameters for that particular track. The track is now selected, and we can see that that track was 414 frames long, 13.8 seconds, etc. So this is a nice way to visualize different tracks. We can see the sinuosity, for example, if we compare this one, which is much more sinuous, compared to this track up here. We can also only visualize certain tracks. So this interference dialog here, if we only want to see the tracks where the bat actually flew through the rotor swept zone, then we would set interference to yes, and we'd see that these 4 tracks, can visualize this here by looking at it from above. Oops. We can see that in these 4 tracks, each one of these bats flew through the rotor swept zone. Or if we set that to no, then these are the tracks where it did not fly directly across the rotor swept zone. One of these came very close, but it did not actually cross that plane. You can actually also go through here and select or unselect certain ones, so you can just visualize the ones you're interested in. So that's an overview on how to generate and visualize 3D tracks in ThruTracker. Thank you, and we'll see you next time.